Hello. Good afternoon, everybody. Thank you for coming to my talk, Mastering Spring Boot's Actuator. My name's Andy Wilkinson. I work for Pivotal, where I'm a member of the Spring Boot team. Just before we kind of really get properly started, quick show of hands. Before you'd heard of Spring Boot's Actuator, how many of you actually knew what an actuator was? If you think you know what it was, can you stick your hand up? Well, it's maybe 10% or so. All right, I didn't know either. So an actuator, it's one of these. So hopefully it's all completely clear now. You know exactly what's going on. So it's actually a mechanical device for moving or controlling something. So rather than talking about a mechanical device, we're talking about Spring Boot applications. So we've got a module in Spring Boot. So rather than the device, it's the module, and the things that we're controlling are Spring Boot applications. So you can control them in terms of shutting them down or changing log levels, or you could also use the information that you get from the actuator to help you kind of keep control of your application. So that's where the name comes from, in case you were wondering. All right, so I'm going to split this talk roughly into two halves. To begin with, I want to talk a bit about what's new in the actuator, kind of looking at things from the outside in. So we'll look a bit about how to configure the actuator and the endpoints and things that are available for you out of the box in Spring Boot 2.0. And then in the second half, we'll take a deep dive into how to write your own actuator endpoint. So this will be going into a bit more detail with the things that you've already seen a little bit of if you were in Madura's talk yesterday, or if you were in Brian and Stefan's talk this morning, you've seen a tiny little bit of that. And I'm going to go into it in a bit more detail so that you hopefully can go away knowing exactly what you need to do if you want to write your own endpoint and add it to the actuator. All right, so to take a look at what's new, let's create ourselves an application, and there's nowhere else to start other than start.spring.io. I'm going to do it via Eclipse, and the Wi-Fi's working, which is a good start. Right, so add some dependencies to our app. Let's add the actuator. Let's make a web app because we want to expose our endpoints over HTTP. And then let's add DevTools just to speed things up a little bit. All right, so start.spring.io will generate our app for us, and we just end up with a usual empty Spring Boot application, but in our POM file, we have the actuator dependencies and the various other bits and pieces. Is that text big enough at the back? No, okay. So there we just have the usual three dependencies. We've got the actuator starter, the web starter we added, and DevTools that we added as well. So if I start that application now, once Eclipse has done a bit of indexing, we'll see it starting up, and we'll end up with the standard set of endpoints that are available out of the box in Spring Boot 2.0. To start with, let's take a look at how things look from JConsole. So when you start a standard Spring Boot 2.0 application up, things are exposed differently depending on whether you're accessing your application via JMX or via HTTP. So if we look at things in JMX, you can see that there's quite a long list of endpoints that are exposed. And the reason for the difference is that we consider JMX to be more secure by default than HTTP. Unless you've configured the JVM to listen for remote JMX connections, the only person who can access your app via JMX is somebody who can run something on the same host. So it's inherently more secure than HTTP. So out of the box, we pretty much expose all of the endpoints over JMX, but we only expose one or two over HTTP to try and keep things as useful but as secure as we can out of the box. A few things to point out here, little differences between Spring Boot 1.5 and Spring Boot 2. A few of the endpoints have changed names just to hopefully better describe exactly what they do. So for example, the the AutoConfig endpoint is now called conditions. The reason for that renaming was to better reflect the fact that you don't actually have to be in an AutoConfiguration class to use a condition. You can use a condition in a plain configuration class. And what the endpoint is showing you is the evaluation of all of the conditions, whether or not they were in AutoConfiguration or just in normal configuration. The HTTP trace endpoint has also, that used to be called trace. We just renamed that to better identify the fact that it is talking about tracing HTTP requests, so to reflect the endpoint's purpose a little more accurately. And there's also a new endpoint here, the scheduled tasks endpoint. I'll talk a little bit more about the new endpoints a little bit later on. There's also another new endpoint that doesn't appear here. We have an endpoint for exposing information about sessions that are being managed by Spring Session. The reason it doesn't appear here is because I don't have Spring Session on the class path. So without it there, the auto-configuration for it hasn't kicked in. If you add Spring Session to your class path, you'll also get an endpoint for it out of the box. So if we now take a look at things from HTTP instead, you'll see that there are a different set of endpoints available. Can you read that at the back? Let's make it bigger. Okay, so I guess the first thing actually is, and this has already been mentioned this week, all of the endpoints are now grouped under /actuator. So I made a request here to 8080/actuator. The reason that we did that out of the box in Spring Boot 2.0 is, there's a couple of reasons really. One, grouping all the endpoints together makes it a bit easier to secure them because they're all mounted underneath the same common path. Another reason is that it lowers the chance that an endpoint is going to clash with a request mapping that you've got in your own application. Before, when they were all in the root of the application, if we have 10 or 15 endpoints, that's 10 or 15 request mappings that you can't use at the root of your application. Otherwise, there's going to be a clash between the two. So we've grouped them all together under /actuator. Although you can change them and move them back if you want them all in the root, and I'll show you how to do that a little bit later. And so you can see here we've just got two endpoints available out of the box. There's the health endpoint and the info endpoint. For the reason that I explained earlier, we consider health and info to kind of be, they're not unlikely to expose sensitive information. Certainly the health in its default configuration of just saying whether the service is up or down. So those ones are available out of the box, but you can enable others. And so let's do that now. So we go into our application properties file. And all of the properties, another change that we've made is to group the properties together as well. So all of the actuator configuration properties are available underneath the management prefix now. It's something that we did. Madura talked a little bit about this yesterday. We tried to review the configuration properties and rename them and kind of group them better to make them more discoverable. So everything actuator related is now under management. So we have management.endpoints. So this is saying management.endpoints is basically the configuration namespace for everything that affects all endpoints. So I can say management.endpoints.web.basepath. And that would let me, so if you set that to /, that will move all the endpoints back under the root of the application. And you can see with DevTools running here, it's restarted the application. You can see now the endpoints have moved to /health and /info rather than being under /actuator/health and actuator/info. Right, another thing, so I talked a little bit about the way that the endpoints were exposed. And we have different exposure by default for JMX and the web. And you can configure that as well in application.properties. So there's a web.exposure.include property. So this property takes a comma-separated list of the endpoints that you want to expose. And there's an include property and an exclude property. And the exclude property takes precedence. So you could say, for example, in fact, in the include, you can use a wildcard. So you can basically say, I want to expose absolutely everything. But then you might want to say, actually, there's one or two of them that I don't want to be exposed. So if you use the wildcard in include and then individually list a handful of endpoints in exclude, the exclude property will win. So it will override the wildcard and exclude a few of them from being exposed and being accessible via HTTP. There are also similar properties for JMX, just with different defaults. So there's a management.endpoints.jmx.exposure include and exclude as well, that have similar effect for whether or not the endpoints are exposed via mbeans. The other thing to show you is I said that almost all of the endpoints were available out of the box. There's one, the shutdown endpoint, that we don't even enable by default. So not only isn't it exposed, it just isn't enabled at all. So every endpoint that we have in Spring Boot automatically has an enabled property. So you can see here, for example, management.endpoint.beans.enabled. So every endpoint has an ID, and that is then used to automatically generate configuration properties for the endpoint based on the ID. So management endpoint beans enabled, and almost all of them default to true. So they're enabled by default, and then you can decide whether to expose it via JMX or via the web to make it accessible via HTTP. The shutdown endpoint is completely disabled. So you can set that to true, and that will switch the shutdown endpoint on now. And the default JMX exposure rules mean that it will now be exposed. But if you wanted to make your shutdown endpoint available over HTTP, you'd have to open it up and say, I want to include this in the endpoints that are exposed. One thing that this isn't actually strictly related to the actuator, but a change that I really like in Spring Boot 2.0. I'm running DevTools here, so the context is automatically refreshing whenever I make a change. And something that DevTools will do for you now is when you make a change, it will output a delta for you of the condition evaluation that changed. So here you can see now that a change that has happened is that the auto configuration for the shutdown endpoint has now matched. It's now been switched on. And that was a result of me setting that property to true. So when you're developing a Spring Boot app and you're changing configuration settings, or you're adding beans or removing beans, the auto configuration delta that DevTools gives you will let you see how Spring Boot is reacting to the configuration changes that you've made. All right, so another change, let's just expose them all again. And then another change that's come in Spring Boot 2, and this has been mentioned a little bit already, is to the security model. So let's add the security starter to our application. One thing, unfortunately, DevTools can't cope with is adding new dependencies, because you can't change the class path completely while the JVM is running. So if I restart the application, we've now got Spring Security on the class path, and all the endpoints are now locked down. If you now add Spring Security to the class path, we make things completely secure out of the box, and you don't get access to anything. So you'll get an HTTP 401 response. So you might want to open things back up again. You might want to make some of the endpoints available without requiring security, or you might want to customize the security that they require. And the way that you do that is really just standard Spring Security configuration. So you would extend Web Security Configurer Adapter, just as you normally would if you were setting up your own application security. And you want to override the configure HTTP security method. And this is the bit where the actuator kind of specific piece comes in. So you say authorize requests, and then Spring Security is heavily based on matches that decide, well, does this request match these particular security rules? And as you've already seen, if you were in some of the sessions earlier today and yesterday, there is a factory class in the actuator called Endpoint Request that will let you generate a request matcher that matches particular endpoints. And we provide two variants. One if you're using plain Spring MVC, a servlet-based app, and also one if you're producing a Web Flux-based app, so if you're doing reactive stuff. The programming model for Spring Security is slightly different for a reactive application because it all has to be non-blocking and stuff, and it can't rely on the servlet API. So there are two endpoint request classes, each in different packages. So if you're switching between MVC and Web Flux, just watch that you're using the right one. Hopefully I'm about to use the right one now. So you can say request matches, endpoint request, and then there are various methods on there to say, to target a particular endpoint, to target any of the endpoints. And you can identify endpoints either by class or by string. And when you're using a string, it's basically the ID of the endpoint. And we'll see exactly how an endpoint gets an ID in the second half of the talk. But I'm going to use the class variant here. So I can say, well, let's open up the health endpoint, for example. And then let's say, let's permit all. So let's open the health endpoint up completely to anybody who wants to access it. But then I better lock other things back down again. It's probably not a good idea to leave everything permit all. So let's do an ant matcher. And let's just say for absolutely everything. Actually, let's do has role user, and then let's switch on HTTP basic. So if I save that, we should now hopefully, if we go back here, and I query the health endpoint, so I can now access the health endpoint, but if I, for example, try to go to the info endpoint, it's still locked down. So that the endpoint request class is kind of a useful way for you to customize your endpoint security. And it means that you don't need to worry about, well, which path is this endpoint going to have? If you change the base path to move things, if you've mapped an endpoint to a different path, you don't need to know, for example, that health endpoint maps to health in its URI. You can just talk about, it's more a declarative way of doing things. You're just saying, well, permit access to the health endpoint. I don't care exactly how that happens, exactly what its request mapping is. So hopefully it makes it a little bit easier for you to tailor your application security when you're using the actuator. Right. Another thing that you can do, and that we saw a little bit, the health endpoint allows you to control what access you get to it. So as Madura mentioned, we went back and forth on this a lot in Spring Boot 2.0. In Spring Boot 1.5, I think I can safely say, well, certainly I couldn't have described to you succinctly the rules for what the health endpoint would show you in any given situation. And from the feedback that we heard, I think a lot of users were confused too. So we've tried to simplify that in Spring Boot 2.0. We got a lot of really good feedback during the milestone phase. We went backwards and forwards quite a lot, as Madura mentioned. So now the health endpoint has a property that lets you control when it will show details to you. So there's show details, and it has three possible values. Never, so only ever show whether it's up or down. You can say always, so you can say, I don't care who's accessing the endpoint. If the security rules mean that they can access it, show them everything. Or there's also perhaps the more interesting setting is to say, well, I only want to see the details when it's accessed by an authorized user. So if I save that now, if I go back here and I look at the health endpoint, you can see all it's told me is that the service is up. So our default Spring Security auto-configuration is generating a random password every time we start up the application. So if I now access that using that password, you'll see that I've got all the details. So it's just basically locked down to, if you haven't authenticated, you're just told, yeah, it's up, or yeah, it's down. But if you have credentials that allow you to access the endpoint, then you're allowed to see more information. And you can configure the roles as well. So you can say it doesn't just have to be that you can authenticate, it's that actually you have to be authorized as well. And you can use this as well in your own endpoints, and we'll talk a little bit more later on about exactly how you would go about doing that, and how the Actuator endpoint programming model gives you access to the information to decide whether or not a user is authorized and should be allowed to do something. The last thing that I just wanted to quickly show you, things that are new in Spring Boot 1.5, in Spring Boot 2.0. Let's simplify things a bit briefly. We'll take security out of the picture for now. So one of the big motivating factors for the changes we made to the Actuator in Spring Boot 2.0 is we knew that Web Flux was coming, and we knew that we had to support it. And we didn't want to say to people, oh, if you want to use Actuator, you have to use Spring MVC, because it would cut off the Actuator to a whole class of applications. But we also knew that we didn't want to rewrite we didn't want to duplicate the Actuator. We didn't want to have basically two actuators sitting side by side, one doing reactive stuff, one doing MVC stuff. So we set ourselves the challenge of thinking, well, I wonder if we can come up with something that will allow us to run the Actuator on top of both. And that's thankfully where we managed to end up. So if I change my application dependencies and I change starter web, so here I've just changed starter web to starter web flux, and I start my application back up again. From an external perspective, nothing really changes. The infrastructure, the endpoint infrastructure in the Actuator adapts, and the only real clue that you get is that there's now a handler mapping that's using Web Flux. So the Actuator's infrastructure automatically adapts your endpoints to run on top of whatever web stack you've decided to use. We can also do the same thing with Jersey. So if you're a fan of the JAX-RS programming model and you prefer it to Spring MVC, if you want to use Jersey in your app, in Spring Boot 1.5, you had to have Spring MVC on the class path as well, purely to be used for the Actuator's use, which is a bit of a waste. It makes your application a bit bigger, it uses a bit more heap. So what we were able to do in Spring Boot 2.0 is use kind of the same adaptation technique that we use for Web Flux to also adapt the endpoints down onto Jersey as well, if that's your preferred web development framework. All right, so I'll just recap a little bit what we went through there. So the endpoints have moved under /Actuator, as I mentioned, for two reasons. One, slightly easier to secure, and also to hopefully avoid clashes with your own request mappings in your application. If you want to move them back, we heard from a number of users who they work in a reasonably large organization, and they have monitoring systems perhaps that needed health to be available at /health, for example. And they didn't want to have to tell the operations team, this is a Spring Boot 2 app, so you need to use this URL, whereas this is a Spring Boot 1.5 app, you need to use this one. So we've made it configurable so you can move everything back should you need to do so. The two properties for deciding whether things should be exposed, so the include and exclude properties. As I mentioned, there's a pair of properties for web and a pair of properties for JMX. The web ones are more locked down by default for security reasons. JMX is more open. And you can also enable or disable endpoints completely. I've used the Shutdown Endpoint here as the example in the slides because the Shutdown Endpoint is disabled completely by default. And you can use management.endpoint the ID of the endpoint and then enabled to control whether it's available at all, and then decide what technologies it should be exposed over. Endpoint request to hopefully help you secure your Actuator endpoints a bit more easily when you're customizing your Spring security configuration. And lastly, the actuator has learned how to work on top of Jersey and Web Flux, in addition to this, the Spring MVC support that we had in 1.5. Another thing that I should have put on this slide is that all of the endpoints have basic caching support now as well. For simple operations on the endpoints, the actuator will automatically cache the responses from them for a period of time. And every endpoint has a property that's automatically generated for you that can be used to control what the time to live on that cache may be. And so you can set it to 0 if you want to disable the caching for any particular endpoint. And it works for simple read operations. So any read operation, when you're requesting information from an endpoint, the actuator can cache that response for you. Previously, that was something that only the health endpoint offered in Spring Boot 1.5, and we've generalized that now so it's available across all of the endpoints in the infrastructure, should you wish to make use of it. Scheduled task endpoint, so a new endpoint in Spring Boot 2.0, available by default under /actuator/scheduled tasks. I really like this endpoint in no small part because it was inspired by a proposal from a contributor to the project. Unfortunately, unbeknown to them, when they submitted the pull request saying, I think this would be really useful, Stefan and I were busy rewriting all the actuator infrastructure. So we unfortunately, while their idea was hugely useful to us, unfortunately we didn't use the code, but it not only inspired the endpoint that ended up in Spring Boot, but it also inspired some improvements in Spring Framework that made it easier for us to introspect the information about what scheduled tasks you've got running in your application. Here's some sample output from the endpoint. You can see here, so here's, for example, a cron task. And the actuator will tell you, so the runnable target is the method that's going to be called, and then the cron expression controls the times at which it will be invoked. We also do the same for fixed delay and fixed rate tasks, displaying similar information, the method that will be called, the initial delay, and then the frequency. So if you've got an app running somewhere and you think a scheduled task isn't running, or you're not quite sure what's going on, the scheduled task endpoint is a useful way, hopefully, to introspect things and check that your scheduled task configuration is as you expected it to be. Another new endpoint that I mentioned earlier, the sessions endpoint, /actuator/sessions. This one was contributed by Vedran Pavic, and his code did make it in because he wrote it after we'd rewritten the infrastructure. And this gives you information. You can ask it for a particular user. You can say, tell me all of their sessions, please. And it will tell you things like the creation time, last access time, whether or not it's expired. And it also has some more sophisticated operations on there. For example, you can delete a user's session if you want to forcibly expire one of them. We've also got new web API documentation. So in Spring Boot 1.5, we had an actuator docs module, which you could drop into your app, and it would kind of self-host some actuator documentation. How many of you knew that module existed? Yeah, that pretty much matches the download numbers for it as well. It became apparent that not many people knew about it, and it also had the problem, because it was this module that was hidden in Maven Central, Google or DuckDuckGo or whatever your search engine of choice is, it had no idea it existed either, so nobody could find it via a web search. So in Spring Boot 2.0, we pulled it out, and it's now part of the documentation that's published to docs.spring.io. So there is detailed actuator reference documentation that covers every single endpoint and describes the request and response payloads, the fields that they expect to get. So you can see, for example, the scheduled tasks thing, and you can see that content there is the stuff that I used when I was preparing the slides. So documentation all produced using Spring REST docs, so hopefully it's accurate. So yeah, please, if you're getting started with the actuator, or you're coming from Spring Boot 1.5 to Spring Boot 2, and you're trying to understand how things have changed, how the payload formats and things have changed, hopefully the new API documentation will prove very useful. Lastly, big thing that changed is metrics. I'm not going to really say anything at all about metrics, other than to say we've now integrated the Micrometer library, which is another open source project sponsored by Pivotal. Biggest difference with Micrometer is that metrics, or one of the biggest, is that metrics are now multi-dimensional rather than hierarchical, so you can tag an individual metric with lots of different bits of information, and it allows you to drill down on metrics depending on, whether what the response code was, or whether it was a GET request or a POST request. There's all sorts of different ways now you can drill down based on the tags. If you want to know more, then I would recommend joining Michael in this room this afternoon at 15:30, and he will take you through Micrometer in 50 minutes worth of detail and how it relates to Spring Boot applications and Spring Boot metrics. So, writing your own endpoints. I've got 20 minutes left, so I haven't quite got half. I now want to take you through, leading you through by example from some Spring Boot code. So I'm going to show you bits of code from endpoints that are in Spring Boot. So if you want to see them in context, you can go to GitHub and look at the Spring Boot repository and find this code there and play around. When you're running your own Spring Boot apps, this is the actual code that's running there. So let's start by looking at the sessions endpoint. So the first thing to note is that for a class to be considered an endpoint, you annotate it with this new endpoint annotation. So for an endpoint to be picked up by the actuator infrastructure, it has to be annotated with endpoint, and it has to be exposed as a bean. So you could put component on there as well, or you could return it from a bean method. Up to you. Either will work just fine. And this is where the ID comes from. So every endpoint, the annotation has this ID attribute, which controls the ID of the endpoint, which influences the various properties that I showed you earlier on. And it will also influence. So we take that ID, and when you're exposed over the web, it gets pushed down into the URL. So it's /actuator/ the ID of the endpoint by default. It also influences the name of the mbean in JMX. So this endpoint would be called, the mbean for this endpoint would be called sessions based on the ID that's been specified. So the other concept that we have in the new endpoint infrastructure is the concept of an operation. So an operation is something that you can invoke on an endpoint. And there are 3 different types of operations. There are read operations, write operations, and delete operations, which get, in the JMX world, they all just get mapped to mbean calls that you can make. In the HTTP world, the mapping's a little bit more interesting, a little bit more complicated, so that's what I'm going to focus on now. So there's a read operation annotation. So if you have a class annotated with endpoint and exposed as a bean, if you put read operation on a method, then the endpoint infrastructure will expose it via JMX and via HTTP. You can take input into an operation. So for example, the sessions stuff, I said earlier that it could list all of the sessions for a particular user. And then whatever you return, it will automatically serialize to JSON for you. So here we're returning the sessions report, which is the detail of all of the sessions. So again, this is a read operation, so it maps to an HTTP GET request. The ID of the endpoint is sessions, so we have sessions in the URL. And then this input into the endpoint, the username, it gets mapped automatically by the web infrastructure into a query parameter. So if we wanted to get all of Alice's active sessions, we can use username equals Alice on the end of the URL. And the endpoint infrastructure will automatically take that query parameter and then pass it into your method via the username parameter. Another read operation here, this one's subtly different. So again, it returns a type that gets serialized to JSON, but more interestingly about this one, we're using this selector annotation. So the selector lets you home in on a specific thing. So rather than kind of querying and searching, you're saying, I want to identify, in this case, a specific session. And this gets mapped slightly differently. Rather than being mapped as a query parameter, anything that's annotated with selector in the HTTP world, in the web world, gets mapped into a path variable. So this is /actuator/ sessions / and then the session ID. So whatever the user replaces that variable with in their URL, that will get passed into the session ID parameter on your getSession method in the endpoint. There's also a delete operation here, as you might guess. A delete operation, oh, actually I should mention, delete operation, so it returns void. When the endpoint infrastructure finds a method with a void return type, it maps that to an HTTP 204 response. So this is saying there's no content to indicate to the client that it's expected that there will be no body. All of the others, when you are accessing the report of the sessions or a descriptor for an individual session, they'll be mapped to an HTTP 200 response, unless you return null. If you return null from an operation, then that will get mapped to an HTTP 404 automatically for you. Again, we have the selector here, which is going to be used in the URL. So that comes down, and we can make a delete request to clear out a particular session if we want to kind of forcefully expire it. And as you might guess, a delete operation maps to an HTTP delete by default. Going to switch focus now to the loggers endpoint, because this one has a write operation on it, which the sessions endpoint doesn't do. So a write operation lets you kind of make a change, lets you pass information into the actuator to change something. And there we go. Right, so again, the endpoint, the ID, we have loggers in the ID, which will affect the URL. This time we have a write operation. So we're saying here to the endpoint infrastructure, I want to expose something that can make a change to the system. We're returning void again, so as I said, that will get mapped to an HTTP 204, or in the mbean case, it's just the mbean will return void. Again, we're using selector here, so that's going to get pushed down into the URL. And here we also have a log level. So this operation on the loggers endpoint lets you configure a particular level for a particular logger. So you pass the name of the logger using the URL, and then you also need to be able to pass in which level you want that logger to have. And we're making use here of the nullable annotation. So this was introduced in Spring Framework 5, largely in support of Kotlin and being able to kind of offer null safety there. But we also make use of it here to indicate to the endpoint infrastructure whether or not this particular parameter can be null. Is it acceptable for a user to make a request to this operation and not provide this piece of information? And in this case, it is. If you want to remove the configuration of a log level for a particular logger, you can call this endpoint without passing a level at all. And that basically says to the underlying logging framework, just clear out that configuration and then use whatever level is being inherited from either the root logger or one kind of higher up in the hierarchy of loggers. So a write operation maps to an HTTP post. And as we've seen before, we've got /actuator/loggers, so the ID of the endpoint is getting pushed down into the URL. We've got the name, the logger name. It's annotated with selector, so it goes down into the path variables. And then we've also got the configured log level, and that comes in the request body. So when it's a post and you want to pass information into the endpoint infrastructure will automatically look at the body of the request that it's seen, and it uses the name, so the configured level parameter, in your operation implementation, and it uses that for the key in the JSON payload. The way that we do that is we take advantage of Java 8 support for storing information in the bytecode about the name of a method parameter in the source code. So you need to compile, if you're writing your own endpoints, you need to compile with dash parameters passed into to Java-C. So there's a setting in Eclipse or there's a setting in IDEA, and I'm sure in NetBeans to switch that on automatically. If you don't do that, then when we try to introspect your operations, we'll get told that that argument is called arg0 or arg1 or whatever, and then it won't match to whatever key is being used in the JSON. So that's something, a little gotcha to watch out for. If you're writing your own endpoint, make sure that you compile with dash parameters switched on so that Java-C will store that information about the parameter names in the bytecode. Another thing that you can do with the endpoint infrastructure, and you may already be familiar with this, the health endpoint will let you, the health endpoint changes the HTTP status code depending on whether or not the service is up. So if it returns an up response, it will be an HTTP 200. But if the health endpoint returns down, it returns an HTTP 503 response saying that the service is unavailable. And that's obviously web-specific, so it doesn't really fit in a general endpoint abstraction that's designed to be mapped to both JMX and to the web. So you can write an extension. So this is an endpoint web extension. So I'm saying that this is an extension to an existing endpoint that is specifically for when it's exposed via the web. And you target, whenever you write an extension, you target a specific endpoint. So here we're saying, I want this to be an extension of the health endpoint. And we're declaring a read operation, but we're using this web endpoint response return type. And it's genericized, so this is a web endpoint response of health. If you're familiar with Spring MVC's response entity return type, it's basically the same. It allows you to influence both the HTTP headers that are sent back, but also the HTTP status code in a similar way that you can with response entity in Spring MVC. The only reason for not reusing response entity is because we wanted the endpoint infrastructure to be agnostic in terms of the web framework. So we couldn't use response entity because then it wouldn't have worked on Jersey or it wouldn't have worked on Web Flux because its response entity has some Spring MVC specific stuff in there. The other interesting thing in this extension is the use of the security context. So this is the thing that I alluded to earlier when I showed you whether or not the health endpoint would show any details to you. So you could say, well, only show details when you're authorized. The security context is the thing that lets the extension for the health endpoint do that. It provides you with a web container, web framework neutral way of accessing the currently authenticated user and also to do a user enroll check. So you can ask the security context, can I have the current principal, please? And you can also say to it, is the user in a particular role? So you can ask them, are they in the actuator role or whatever? And it will tell you whether they are or not. And then you can make a decision in your endpoint what response you want to return back to them. So this is how the health endpoint, when you have its show details setting set to when authorized, it uses the security context to make sure there's a principal and make sure that principal is in the required role. And if you're not, it just returns you kind of the rolled up, the service is just up. If you are in the required role, then it returns you all of the details. The last thing that I wanted to mention, so I talked quite a bit about the kind of generic endpoint framework that we have that gets mapped to JMX or gets mapped to Web MVC or Web Flux or Jersey. That kind of very general programming model does have some limitations in terms of what you can do in your endpoint. Because we didn't want to tie it to any particular web framework, and we wanted to try and avoid having any too much web-specific stuff. It meant that some of the things that you could do in Spring Boot 1.5, if you were happy to couple yourself to Spring MVC, you couldn't do with the more generalized web framework. So we've added an escape hatch for you. There is a servlet endpoint annotation which can be used if you have an existing servlet that you want to expose as an actuator endpoint. You can create a class annotated with servlet endpoint and a little helper method that basically returns to the endpoint infrastructure, this is the servlet that I want you to expose as an endpoint. And what that does is it allows you to, say you have a third-party library that's been implemented as a servlet and you want to expose it under /actuator/whatever. you can use this servlet endpoint thing to adapt it into the endpoint infrastructure. You get all the same advantages of it moving when you configure the base path. It will move, it will be secured via the endpoint request. That will be aware of it. And it's actually how we integrate Jersey into Spring Boot 2.0. So Jersey is made available as a servlet. So as long as you're writing an app that builds on top of a servlet container, you can use servlet endpoints to integrate an existing servlet into the endpoint infrastructure. We also provide controller endpoint and REST controller endpoint. So in Spring Boot 1.5, when the endpoint infrastructure was tied to Spring MVC, you could, if you wanted, in an MVC adapter for an endpoint, you had access to the whole of Spring MVC's programming model. So you could do content negotiation, you could access the servlet output stream, for example, and write stream stuff directly back to the output stream. Basically, anything that you could do in Spring MVC, you could do in an MVC-adapted endpoint in Spring Boot 1.5. Spring Boot 2, the controller endpoint and REST controller endpoints are the equivalent, basically, with the advantage that they work with both Spring MVC and Spring Web Flux. So if you're not already familiar with Web Flux, its annotation-based programming model basically uses the same annotations as Spring MVC's annotation-based programming model. So you can use controller and REST controller and things. So the actuator endpoint stuff with controller endpoint and REST controller endpoint builds on top of that. So you can make use of a controller endpoint or a REST controller endpoint in a Spring MVC-based app or a Spring Web Flux app. And that opens up the whole power of Spring MVC or the whole power of Web Flux to your endpoint should you need it. Hopefully you won't, or very rarely you will. And the price that you pay is that your endpoint is then tied to, if you use servlet endpoint, you're tied to the servlet stack. If you use controller endpoint or REST controller endpoint, you get tied to MVC or Web Flux, and it won't work if you have other apps also using Jersey. So depending on the audience for your endpoints, and how widely they're going to be used and how diverse the applications that are going to be using them, the different environments that you're deploying things into, you might want to steer away from these and stick with the more portable, the more general purpose endpoint framework, rather than kind of homing in and really kind of going to town on doing something that's Spring MVC specific, for example. Another disadvantage with any of these is that they're not available via JMX. So you lose the ability to access them via JMX. So I would encourage you, if you can, to make use of just the standard endpoint infrastructure with using the web extension like we saw for the health endpoint for specific cases where some slightly different web-specific behavior is justified. And only use these as an escape hatch when the standard infrastructure doesn't give you quite what you need. Then they're a good choice. But other than that, stick to the standard infrastructure. And that is pretty much all I had. Hopefully that gives you the information that you need to go off and make use of Spring Boot 2.0's actuator and also to start writing your own endpoints. If it doesn't or anything's not clear, then please come and ask questions. I'm around for the rest of the day. I'm more than happy, if you see me wandering around, just grab me and ask, and I'll be more than happy to help you if I can. If you can't catch me today, then I'm regularly on the Spring Boot Gitter channel as well, so if you have questions, please ask there, or catch me on Twitter, and I'll do my best to help you. Thank you very much.